Hi everyone, my name is Thomas Kim. Today is January 20th, 2019. This is my fifth episode about graph in C++. So I'm going to talk about graph implementation in C++ language. Why am I talking about std unique ptr, auto reference, and function return type, decl type auto, if constexpr, all these things? You probably think these are not related to graph algorithm itself. Well, I have different idea. I'm going to explain how to implement library for graph in C++. Okay, so if I don't cover these things, preliminary things, when I try to explain the algorithm in C++ language for graph, you probably cannot understand what I'm saying. So before I delve into implementation of graph, I want to clear out the preliminaries, the fundamentals that I will be using to implement graph algorithm. Okay, please understand. Also, I do not film videos to make money out of my videos. I have been in IT industry over 30 years as a profession. I do know what keyword could attract more visitors to my YouTube channel, but I use my own terms and terminologies. I do not use fancy terms to gain unwanted audience. I film for hardcore programmers. Some people call it lazy evaluation or deferred evaluation, but I do not want to use such terms in my videos. Instead, I call this technique breaking tie. Breaking tie, breaking the relation with the enclosing class and its member function by introducing template member. In some sense, deferred evaluation is more adequate, but still the concept of breaking tie can better explain this technique. Template member is the syntax, but breaking tie the semantics of this programming paradigm. Without further ado, let's get started. Please understand that this is my fifth video about graph in C++. So if you haven't watched my previous video, this video, please double click this link and watch my previous video and come back to this current session. I start Visual Studio Code and on the CPP extension graph subfolder, click 05 unique ptr.cpp, hit enter. Ctrl V, include talk platform output HPP. Talk platform SS stream auto and there talk platform and there. Now we are introducing template, type name, element type, class, dummy, class. Don't forget semicolon here. Public. We are defining type alias. Unique ptr. It can make you confused, so I say uptr t std unique ptr element type. So we declared a unique ptr type and named it uptr. So I will create more type using L value ref. I just say L ref uptr t, then std unique ptr element type. This is reference. Okay, of course we can do this using lref uptr t. We can use uptr t. Sorry, I have to put here. This is exactly the same. These two things, cut, paste. This is for your reference. Okay, now I will define one more using constant lref uptr t, constant lref uptr t. This is exactly the same using constant std unique ptr element type. This is reference. If it makes you get confused, I will do like this. I don't want you get confused. Okay, anyway, this is uptr unique pointer, and this is L value reference unique pointer. This is L value reference, and this is constant L value reference using ref uptr t. This is R value reference std unique ptr element type. This is R value reference. So I defined some type alias. Now private. So I'm going to use uptr t member public dummy class. So element type say value. I will just initialize. In this case, okay, m member. Now we initialize like this std make unique element type value. So we define the constructor. Up to this point, you should have no problem understanding what we are doing. Okay? Now here, type. So we are introducing this type and get member. So return static cast type this m member. Okay, so we have to break tie. Okay, from this dummy class and this get member function, these two functions are tied, and we break the tie like this. Template type name type. we introduced template parameter type, okay, which breaks the tie between dummy class and its member getMember function. How this getMember and this member are bound through this template parameter, okay, so which breaks the tie between dummy class's template parameter element type. I hope you understand this concept. Now with this function, we will test void test get member int main. I call this function dummy class. I can say double, okay, dummy. We initialize any value 22.0 over 7.0. So we initialized dummy. Now auto p1. Auto is copy semantic. I will talk more about keyword auto very soon. Dummy. Now get member. Okay, we will call this member, and here we will initialize default value. Default value is L value reference. Okay, this is L value reference. Okay, please don't forget this. No, constant. Okay, this is constant L value reference. Now with this is reference now, so it should be like this. String the value of the object that p1 is pointing to is p1, and there. This is reference. Default value is, this is constant. Okay, now let's build if it works. Start command prompt dir clang ++std c ++1705 unique ptr.cpp, hit enter. Class cls, hit A. So the value of the object p1 is pointing to is 3 point blah blah blah. This is smart pointer, unique ptr reference. Now we can get the type. String the type of p1 talk play fun get type category p1. Okay, now auto reference p2 dummy get member. We will introduce using dummy t dummy class double. I will copy it here and using then dummy t. Okay, these are exactly the same. Now at this point dummy t, this is L value reference. Okay, now let's try it if it works. Copy paste. Now this is p2. What is important is type of p2. Type of p2. And now We copy once again. Copy. Now we are using not reference. Okay, this is not reference. P3. We get ref uptr. Now it is move semantic. Okay. 3 Now let's build once again. CLS A. So in case of P1, the type of P1 is constant unique PTR L value reference. In case of P2, STD unique PTR L value reference. In case of P3, we moved the member. This is, I have to fix this to P3. Okay, I will build once again. CLS A. In case of the type of P3 is STD unique PTR. So this is move semantic. We defined this simple function. We defined only one simple function, but we are returning from this simple function as constant L value reference. As L value reference, then this is move semantic. I use this technique or variants of this technique, similar techniques, quite a lot in my own programming. In next episode, I will talk about more advanced way to return values from a function. I will upload complete source code of this episode to my website, extension talkplayfun.com website. By the time you watch this video, if you click this link and show in folder, unzip it, in CPP extension, grep folder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.